So guys, we have two more problems. The first one is problem number 18. So in the problem, we have calculate the rise of water inside a clean glass. That is rise of water, that is H is equal to question mark. Or tube of a capillary tube of a radius 0.1 mm, r is 0.1 mm, that is 0.1 into 10 to minus 3 meter, m is milli is 10 to minus 3 meter, and that is 10 to minus 4 meter. When immersed in a water of surface tension 7 into 10 to minus 2 Newton per meter. Surface tension of water is T is 7 into 10 to minus 2 Newton per meter, and the angle of contact between the water and the glass is 0. Angle of contact theta is 0. The density of water is 1000 kg per meter cube, that is 10 to 3 kg per meter cube, and the acceleration due to gravity is 9.8 meter per second square. So we have to calculate the height. So inside a capillary tube, height of a liquid or rise of a liquid, so H is equals to 2t cos theta upon r rho g. 2 is as it is, T is 7 into 10 to minus 2, cos theta is cos 0 upon r is 10 to minus 4, rho is 10 to 3, and g is 9.8. So 7 2s are 14 and 10 to minus 2 is as it is, cos 0 is 1. Okay, so 10 and 10 to minus 4 and 10 to 3 become 10 to minus 1 in denominator. In the numerator it become 10 to 1. Okay, so and the 9.8 is in as it is in denominator. So 14 into minus 2 and minus 1, minus 2 and plus 1 becomes minus 1, that is 10 to minus 1. So 14 into 10 to minus 1 upon 9.8. So this is 1.4. The reciprocal of 9.8 is 0.1020. Okay, so the answer is after multiplying by 14 or 1.4, you can do in both way and just shift the decimal point if you multiply by 14. So therefore H is equals to 0.1428 meter. The next problem is problem number 19. An air bubble of radius 0.2 mm. Air bubble has a radius 0.2 mm, that is 0.2 into 10 raised to minus 3 meter, that is 2 into 10 raised to minus 4 meter. Situated just below the water surface. Calculate the gauge pressure. Gauge pressure, that is difference in a pressure, that is Pi minus P0 is equals to question mark. Calculate the gauge pressure. Surface tension of water is 7.2 into 10 to minus 2 Newton per meter. The surface tension of water is 7.2 into 10 to minus 2 Newton per meter. So according to Laplace law of a spherical membrane, we have the formula for the drop in case it is a bubble, right? But for the bubble we take the formula as a 40 upon r. But bubble, when it is outside the liquid surface, it has a two surfaces which are in contact with air, that is outside and inside. But in this case this bubble is inside the liquid, so only its inner part or inside part is in contact with the air. So we'll take the formula for the drop instead of a bubble, and that formula is Pi minus P0 is equals to 2t upon r, because there is only one surface that is exposed to the air. So therefore 2 is as it is, T is 7.2 into 10 raised to minus 2, r is 2 into 10 raised to minus 4. 2 get cancel. दोन्ही surface contact मध्ये नाही आहेत हा इथे एअरच्या. ओके, कारण जर बबल जर आउटसाइड द लिक्विड सरफेस असेल, म्हणजे तो एअरच्या कॉन्टॅक्ट मध्ये असेल, तर इनर आणि आउटर दोन्ही सरफेस आहे ते एअरच्या कॉन्टॅक्ट मध्ये होतील, मग आपल्याला 40 अपॉन आर घ्यायला लागेल फॉर्म्युला. बट ह्या केसमध्ये तो बबल कसा आहे, आतमध्ये आहे, लिक्विडच्या आतमध्ये आहे, त्यामुळे त्याच्यातला त्या बबलच्या आतला पार्ट फक्त एअरच्या कॉन्टॅक्ट मध्ये आहे, म्हणून आपण फॉर्म्युला म्हटलं घेतला ड्रॉपचा घेतला. बबलचाच आहे, फक्त त्यामध्ये 2 घेतला नाहीये. ओके, म्हणून तो ड्रॉपचा फॉर्म्युला झाला, दॅट इज 2t अपॉन r. सो 2 गेट कॅन्सल. 7.2 10 to minus 2, minus 4 shifted to the numerator becomes plus 4 and minus 2 is 10 to 2. So 7.2 10 to 2, that is 720 Newton per meter square.